Okay, good morning, everybody. Well, first of all, I really would like to say that the International Center for Theoretical Physics is an enthusiastic supporter of this project, Sharing Knowledge in the Mediterranean, that is led by Robert Klapisch. And as you know, we have been involved in holding a meeting 2 years ago, and then we participated in Montpellier and so on. Today I want to give you some information about some new activities, new directions that are happening in this center that, as you know, started in 1964. So some of the aims originally were connected to what Chris said, because as you know, near Trieste there were many nuclear missiles in direction of the Soviet Union, and so the ICTP was a place where USSR and American scientists could get together and talk about various matters. And then sometimes, you know, talking about things that go beyond science. Here I show you the... Oh, okay, thanks. So I show you here the main lecture hall, the Miramare, and the buildings of ICTP, and some of you are already familiar with the center. Let me give you also here's some information about the location of ICTP and the science system in which it is now embedded. When we started 44 years ago, you know, we were the only big research institution around there besides the University of Trieste. And now there is really a cluster of many institutions. And ICTP contributed to the development of many of them. For example, there you have the Third World Academy of Sciences, which is on the Miramare campus, to us. Then you have the International School for Advanced Studies, which is an Italian international school for PhDs. Then not far from the center you have the ICGB, the International Center for Genetic Engineering and Biotechnology, the UNIDO International Center for Science. So these are all international institutions. But then you have also the Italian Institute of Nuclear Physics, Synchrotron, Trieste, hospitals, and then there are other universities in the region. So we are trying to connect all this. So when people from developing countries access ICTP, in a way, automatically, they assess the whole Trieste science system. Now, some of the basic information about the ICTP, to remind you that it was founded in '64, operates under a tripartite agreement between IEA, UNESCO, and the government of Italy. Actually, ICTP started as an IEA organization, and only in the early 90s it became, you know, part of this trilateral agreement. So the mission is to foster advanced studies, but with attention to developing countries. So partnership with developing countries is a very important aspect. Most of the funding comes from the generous support of the Italians. And again, I say here that sharing knowledge is very important. So you see, we started with the same concept on which, you know, the Robert Foundation is working for the Mediterranean, sharing knowledge. So we are really an exception within the United Nations system because we really have a real scientific group doing science. These are the groups in high energy, condensed matter, mathematics, earth system physics, which already started under Abdul Salam. And now we have a new section which is applied physics, pulling together a variety of activities that we were having since the early days. And now this area, for example, is related to medical physics, energy systems, and then application of accelerators, optics, and so on. I will tell you more about this later. That is part of the new directions. And then we have laboratory activities. That is also some new direction. Now, what about education? Well, just to let you know some of the basic mechanisms that we have. There is a diploma master program for people who just got a degree in the developing countries, and they want to have 1 year intensive studies in order to be ready for a good PhD in any country on the planet. Then we have a sandwich PhD program. People getting their PhD at home, but they can come to ICTP for 3 years, few months every time, and or to ICTP or associated institutions. So this is a very successful program, which is also funded by the IEA. So it's a program that we are running jointly with the IEA, and obviously we have the ICTP ELETTRA users program that includes also in the last years training people who are working in the Sesame project. Actually, we have a strategic kind of agreement with ELETTRA, and in order to involve in general people from developing countries in the program at the ELETTRA facility. You know now ELETTRA is also building the new free electron laser, so that will be also a world-class facility that will start running in about 2010, 2012. Another program is that is a training, training and research in Italian laboratory. This is another mechanism. We give fellowship to spend time in Italian laboratories, and 1 year, say, for young scientists that already have a PhD, and we had nearly 1,000 fellows in the last 20 years that really went to 339 Italian laboratories. And laboratories include also ELETTRA, as you see here, but also other accelerator laboratories that we have in Italy, or a laser laboratory that is in Trieste, which is run also by ICTP, and so on. And then we have, as you know, many schools, colleges, workshop, and the last workshop that we held on sharing knowledge in Mediterranean was part of this kind of activities. But we have about, like in 2007, we had more than 50 activities, plus we held 12 elsewhere, and then we have hosted programs and so on. So in general, we have about 6,000 scientists every year coming to ICTP. 50% of these scientists are from developing countries, because that is really we want a mix of 50-50 in order for the benefit of people from developing countries. And about 100,000 is the totals, if you want, to total number of scientists that came to ICTP in the last 30 years. And this is some visitor statistics from different countries. You see like 10,000 visitors from Africa, and 7,000 from Asia, and 8,000 from Latin America, and so on. Many from Europe, 30,000, obviously, given the proximity of Europe. Now, let me give you some more specific comments. Well, first of all, we talked about environmental aspects yesterday. We didn't talk much about earthquakes, so let me just say a few words about our involvement in earthquakes. So this is the Africa-Eurasia plate boundary, and you can see that, for example, Trieste is really located, originally was located in the African plate. So if you go back to the Jurassic, Trieste was really in Africa. We still are in the African plate. So this creates obviously other problems, like the earthquakes that you have in the North African side. And so we have our group in earth physics involved in monitoring earthquakes, predicting these earthquakes, and so on. Like this one, I'm showing the earthquakes 2003 in Algiers, which created, for example, this kind of effects, like an uplift of 0.5 meters. So this is a really big effect. So you see here, our colleague from European Commission was asking why we need to be involved in projects in Africa and so on as Europeans, but you can see that this could be, you know, a symbolic way that an earthquake in developing countries can create tsunami in Europe. So really, and this could be have a broader, even political meaning. And in fact, here you can see the historical tsunami that since 500 years ago affected the northern part of Europe. There was also one big in Trieste, I think about 500 years ago. About climate, as you know, we also have the Earth Physics Group is involved also in climate studies. Yesterday we spoke about the significance of global climate change regarding regional effects. Europe, the Mediterranean area, as you know, which is really characterized by these two different areas, one temperate wet on the north and hot and dry in the south, will be heavily affected by the global climate, and probably the northern part, the temperate wet part, will become very similar to hot and dry that you have in the south. This is what the programs are saying. You don't see here, but this is the joy of the Macintosh, but this is showing the hotspots in the Mediterranean. This is a paper by Filippo Giorgi, who is the vice chairman in the International Panel for Climate Change, and the size of these spots is related to the size of the local effect that you have due to global climate change. Here you cannot see where the spots are, but I can tell you that the Mediterranean, on the Mediterranean you have a big spot, meaning that you have really a bigger local response to climate change. Another area of interest is the accelerator science and applications. And as you know, accelerators have been developed in the 30s for using nuclear physics, but then there is a big tree of accelerator applications and uses that has grown. And now, you know, in every hospital you would have a LINAC accelerators like this one, for treating, for therapy. Then you have accelerators producing isotopes, accelerators to characterize the microstructure of materials. And we heard about the synchrotron radiation, which is a kind of a special accelerator, and so on. So this is really a strategic area of high interest in developing countries. So we are helping schools on accelerator applications, including ion acceleration and synchrotron radiation. As a matter of fact, this week, the 5-week school on synchrotron radiation is starting at ICTP. And I give you an example. So this is an accelerator, and there are similar accelerators in 3 laboratories in Italy, and we have special agreements. So they can be used for analysis in different applications, for accelerator mass spectrometry, which is another very special analysis for example, radiocarbon dating and other cosmogenic isotopes. This is an example of nuclear microscopy, using really ions in order to get information at the microscopic level. And you see is showing in the bronchus the particles coming from aerosols that have, you see, different composition and so on. So this is work that can be done using ion accelerators. For example, this is some work that I have done a few years ago, and this is dating wine using the bomb pulse that was created by the atmospheric explosion of the USSR and Americans in the atmosphere. So you see the date there from the 50s to now, and there is a bomb pulse until 1962 when there was the treaty, and we had to suspend this kind of game in the atmosphere, and then the carbon-14 started being diluted again, and now it's going back to normal. Now, so if you take a wine from 1964 or 58, etc., measuring radiocarbon with few months error, you can say which is the year. Now, this can be used also for dating human cells. And so this is a very interesting application that is coming out. And I'm promoting a project in collaboration with the International Center for Genetic Engineering and Biotechnology in Trieste, using the accelerator in Caserta, in order you can date really the various, because for example, your brain cells will have the same age corresponding to your age when you were born. But some other of your organs, say the heart, say the liver, say and so on, they really have a different kind of age, because the cells are periodically being replaced, part of the cells. So this is just in general the idea. So this is ELETTRA, so I give you now some another example of ELETTRA. In ELETTRA, we are developing, and that is again my experiment, paleoanthropology. So we are using microtomography, so it's similar to computer axial tomography that you find in the hospitals, but only is 1,000 times more resolution. So, and there is actually dedicated beamline to paleoanthropology at the ESRF in Grenoble also. So this is a new kind of line, and we are also under UNESCO, so we really are promoting the use of science in archaeology, cultural heritage, and so on. So this is done again in cooperation with IEA and UNESCO. And in the laboratories in Trieste, we are also building portable X-ray systems involving developing countries and so on. And just a few words about this multidisciplinary laboratory that we are building. Historically, we had a microprocessor laboratory in cooperation with INFN, but now we are expanding, so we are building a new device that can produce neutrons, X-rays, and so on, a plasma focus source. We are also promoting advanced X-ray imaging, accelerator mass spectrometry, and remote access to different facilities. This is the plasma source that we have been built, and it will become operational in the coming months for training, biomedical application, material science, and cultural heritage. We got some support also from Pirelli, so we are also seeking, for support by private companies. Just the last 2-3 slides very, very rapidly about, you already heard this morning about access to knowledge and information. And as you know, ICTP has been involved for a long time in this kind of activities, distributing e-journals with the difficulties that given to the not having the broadband, also monitoring internet connectivity that Robert mentioned this morning, that project, and low-cost wireless network. Since many years ago, we have been saying that wireless is really part of the solution for developing countries, and I'm glad now to see that this is really, we are moving forward with this idea. So we have pioneered the web technology in developing countries since many years ago, and we had many training courses in order to really enhance as much as possible whatever was available in Africa, for example. And this is really, our group recently got a prize for innovation for developing this system, which allows webcasting ICTP activities, spending very little money. So here you see one of the diploma lecture rooms at ICTP, which is equipped with a fixed system for recording and webcasting the lectures. And so if you go to our website, you can look at the lectures, but you can look also at the the conferences and workshops and schools and so on. And this really system allows you to look at the blackboard, to look at the PowerPoint presentation, to follow the discussion. All that is very, very neatly packaged in order, that you can follow the activity. And this is my second last slide. One of the recent involvements of ICTP, just to show you that we are really getting away from theoretical physics, but still that is the core of our activities. We are really teaching our physicists in developing countries how to exploit, if they have brilliant ideas, say in ICT, in nanotechnology, wherever, or new novel applications in the environment and so on. They really should learn about how to prepare a business plan, how to defend your intellectual property, and so on. So we are really having intensive 1 week schools training on this, so economic development, and this is fully funded by the American Physical Society and by the UK Institute of Physics, and we already had 2 of these activities, and now we are going to start moving them around, expanding, because it's important to keep in mind, the triangle of knowledge that Roberto showed, the innovation, innovation, education, and scientific research is one triangle of knowledge. It's all connected, and we should really have an integrated approach. And what we are really hoping I guess, before Srinivasan goes away, because, you know, there is towards the end of his mandate, to develop under the umbrella of ICTP a new institute related to science for development, pulling together all the activities that we are holding now, and they are a little dispersed. And I hope that then, you know, we can contribute more effectively, for example, in activities like the one that Robert now is promoting for the Mediterranean. Thank you very much.